My name is Daniel Vega. I'm the Federal Program Manager for FC3, which is Nuclear Material Control and Instrumentation. For those of you who are new to this particular work scope, this scope actually supports one of the research campaigns within the Office of Nuclear Energy. It's called the Materials Protection Accounting and Controls Technology Program. That program is familiar to a lot of you as well, but our process has changed slightly this year, and our solicitation will be a little bit different as a result. So I'm going to give a quick overview of the campaign itself, because as I said, this is meant to be a supplement to that campaign. So the campaign mission here is to develop innovative technologies and tools to enable next-generation materials management for existing and future U.S. nuclear fuel cycles. This includes the front end and the back end eventually. To manage and minimize proliferation and terrorism risk associated with these developments in fuel cycle. All right. What that means is that we do a number of things. The backbone is technology development, and that's what we've been focused on over the last few years. The second part is applications of these technologies, and the third part is forming the leadership and the ownership of these methods to confidently track material in, again, future and current U.S. domestic civil nuclear fuel cycles. So with that, I'll give a couple of milestones to tell you kind of where we break down as far as priorities. Two of our 5-year milestones have to do with technology development itself, which means new instrumentation, radiation sensors, and other gadgets and other types of equipment that are used to tell you something about material flows, whether that's physics data or chemical data. Secondly is an application of these as they pertain to pyroprocessing, which is also called electrochemical recycling, a type of reprocessing that doesn't use an aqueous process. Safeguards and security for those have been a focus over the last 2 or 3 years, and we've given solicitations to that effect. That's one of our priorities. We have 2 milestones that pertain to the safeguards and security of interim storage for used nuclear fuel facilities. These are also known as ISPACs. They are going to be spearheaded and developed over the next few years by DOE as part of a long-term waste strategy. And finally, some more physics data related milestones that have to do with determining time-dependent signatures, so we know what to expect in the nuclear fuel cycle as far as tracking materials. Long-term objectives here are ultimately to create an environment of safeguards and security by design as a standard for designing nuclear energy systems, meaning they're not stripped onto the system afterwards. They're not added on, but they're built in tandem with the fuel cycle and with safeguards and security in mind. Second is to demonstrate that the tools that we have created are applicable and are effective at reaching the desired uncertainty goals that we have. That means testing in hot facilities, it means using real nuclear materials, and it means gaining a certain measure of confidence that we can defend to regulators like the Nuclear Regulatory Commission or the IAEA. Speaking of Nuclear Regulatory Commission, another long-term objective of ours is to inform the rulemaking on things like 10 CFR 73, or 74, which cover reprocessing plants and the potential difficulties associated with tracking material in those types of plants. And finally, international engagement on our part means that we support NNSA and we support State Department as necessary when it comes to sharing technology for safeguards purposes, whether that's international or domestic. An example of kind of this long-term thinking here of safeguards and applications is a concept we're talking about called the distributed test bed. It may be a bit tough to read this slide, but if you look on the left, you'll see that vertically that would pertain to a particular fuel cycle. So your facility safeguards, your instrument capabilities, and your analysis tools would all be commensurate with what would be appropriate for that fuel cycle. As those change, you build a database and you build a level of expertise that is applicable to whichever fuel cycle you happen to be looking at. So This does not necessarily mean it's one particular location. It means that these capabilities are just treated in a formalized way so that overall they demonstrate a safeguards capability that we can bring into the future with this. So with that, I'll just say almost verbatim what the solicitation says. And this year we're looking very specifically for advanced safeguards data integration. And I'll just go ahead and read it. So, methods to integrate and distill data from traditional nuclear material accountancy and other data streams to achieve a higher level of awareness of nuclear material flows are being sought. That implies the combination of independent types of data streams, whether that's radiation data, whether that's chemical data, whether it's species data, density, flow meters and the like. As an example of this, Fuel Cycle Technologies has looked at electrochemical processing, where integration of traditional nuclear material accountancy data and advanced process monitoring is needed for real-time accountancy and process awareness. Cycles like these require a different safeguards approach, a batch process versus a continuous process for processing nuclear fuel. And such methods should keep an eye towards decreasing the standard error of the inventory difference by innovative means of integrating data streams of, that's a difficult sentence, integrating streams of relevant process data. That means what I just said earlier. The standard error of the inventory difference is the NRC's way of talking about MUF, or material unaccounted for, which is the IAEA's word. And it is what is used to write regulations. So I would suggest anybody applying for funding in this area look at the Code of Federal Regulations for this definition. In simple language, what we're trying to look for here is ways of combining the large amounts of data that we have, either by generating it or simulating it, and using those to draw overall conclusions about the standard error of the inventory difference, so that we can then inform NRC and ourselves how accurate we can be and to what level of confidence we can assure that no material has been diverted. So I'm ready to take any questions.
Are new sensors development within the scope of this program?
Yeah. This year, no. What we're doing is taking a much smaller scope, and this year we're not specifically looking for sensors. It's likely that over the next years we will take a smaller part of the campaign itself, and that we will be alternating. So one year maybe neutron detectors, one year maybe gamma detectors. This particular year we're looking at ways to integrate data, and not specifically for detector.
Would new X-ray computed tomography methods for material accounting be of interest, or are you interested only in integration of existing methods?
Certainly if the X-ray tomography were to add an additional level of or an additional layer of data that could be used to verify data that already exists of the type as a complement to that, it would be interesting. But X-ray, but alone would not be the focus of the work scope. How it could be used to verify other measurements could be, complement other measurements.
How does this work scope relate to the NNSA's NGSI spent fuel NDA projects?
NGSI spent fuel projects have a lot more to do with verification of declared nuclear material, and most of that is in unit form. Unit form, I mean an assembly. While it's difficult to ascertain the total fissile content, they are looking at an assembly at a time, whereas we're more concerned with what is oftentimes a more difficult problem, which is bulk material. The NGSI program is also focused on an international safeguards focus, whereas we're looking at meeting domestic NRC regulations.
Are you looking for data analysis methods for online monitoring of facility operations?
Yes.
For reducing SEID, are you looking for NDA data on fuel assemblies prior to reprocessing, or only DA data after chopping and dissolving the fuel?
Uh, we're looking for both, as well as as long as they support a decreasing of SEID by being treated comprehensively. So yes, both would be on the table.